Hello friends, now the next topic in feedback amplifier is the types of feedback. This topic, that is types of feedback, is very important for all the exams, that is for GATE, engineering services, public sectors and civil services exam. 50%, I repeat, 50% of the objective type questions in feedback amplifier comes from these types of feedback, from these topics. So from that angle, this is very important topic. You have a lot of questions, and interestingly, this is very simple and very easy to memorize. Let us see one by one. In feedback, we have four types of feedback topology or configurations: voltage series, which is known as shunt series; current series, which is known as series; voltage shunt, which is also known as shunt; and current shunt, which is known as shunt series. These classifications are again on the basis of the type of amplifier which was discussed in previous video, in previous lecture. So we have discussed, we have four different possible signals of this amplifier. What are those four possible signals? Input voltage, output voltage, input current, output current, input current, output voltage, that is trans resistance amplifier. Input is voltage, output is current, that is trans conductance amplifier. On those four, on the basis of those four signals, we had classified these amplifiers into four types: voltage amplifier, current amplifier, trans resistance amplifier, trans conductance amplifier. And these classifications are again on the basis of the signals of input and output signals of the amplifier. Let us see one by one. This is general block diagram of a feedback amplifier. We have a source, we have a mixer. We will see how it mixes the signals. We have a mixer, we have amplifier, we have a sampler which takes the sample of the output signal, and we have the feedback network which feeds the sample of the output signal to the input side. Fine, right? Let us see that one by one. If you remember the general block diagram of what? Control system. If you remember the general block diagram of control system, it is something like this. I have an amplifier here. We have mixer. This is the mixer. This is the mixer. We have output signal here. We have input signal here, right? We have feedback signal which comes from the feedback network, and this is the sampler. This is sampler here, right? This is sampler. So this is this general block diagram of control system which is there. So mixer is, remember, mixer is simple adder or subtractor. Mixer is basically sort of, that is a subtracting type of element. We will see that one by one. I'll explain each and every one. Fine. First, we will be taking the type of amplifier, right? Once you take the type of amplifier, then we will be taking, mixing and out your sampling networks. Let us take first. I will be taking these these different feedback topologies one by one, and we will see what will be there in the block diagram. Fine. Let us take first voltage series, right? First, we should be knowing what is voltage series feedback. We have to identify the input and output signals from the topology. Fine. Voltage series. When you have a signal at one point and series shunt, this is basically type of mixing. This is mixing. This side, when you have a signal at one point, this is mixing. This is sample signal, right? In this nomenclature, we have where we have the signals voltage current or where have series shunt. So second one is mixer, first one is sampled signal. This is the second classification. Here this mixer comes first. Here it is mixer and here it is sampler. So when you have the signal, sampled signal, you can say when you have sampled signal and mixer put together, then sampled signals come first like this and mixer comes later. Like this is one nomenclature, sampled signal and mixer. Second nomenclature is like this, mixer first, sampled signal or sampler later. These are samplers now, these are not signals, these are samplers, these are mixers. Here these are sampled signals, these are mixers. So what has happened? This mixer comes later in this nomenclature, mixer comes later. But in this nomenclature, mixer comes first, mixer sampler or sampled signal mixer. That is how this classification is based on. You must be knowing about this classification. Fine. That is one fundamental concept you need to remember. Now, so in voltage series or series topology, we have sampled signal is voltage. It means what is there? Voltage sampler. In this I'll be taking first let us talk about first, that is voltage series feedback or series feedback. Let us talk about this first. Fine, I'll be taking one by one. I will be explaining in this space all the topologies one by one. Fine. So let us take voltage series or series. So in voltage series, this is sampled signal, this is mixer. In this is mixer, this is sampler. Fine. I have already explained that. Now, voltage is sampled signal. It means there must be voltage sampler here. So we have in this nomenclature, we have voltage sampler. So if you are taking the sample of the voltage, so that means this must be the output signal. So on output side, what is the signal? Output signal. From this it is very much clear. Now let us talk about series. Fine. In series mixer, now this is mixer, series mixer. So there are two types of mixer, you can say. See, series, shunt. So mixer are of two types, series and shunt mixer. So we call mixer signal mixer like this, series, shunt. Fine. We could have classified into third one as well. I will discuss that later. But on the basis of the standard nomenclature given in most of the textbooks, first we will discuss about these. Now, voltage series. So output is definitely voltage, right? So here you please see, this is input, mixer is always at input, sampler is always at output. So sampler is shunt, that means voltage sampling is known as shunt sampling. Voltage sampling is known as shunt sampling. Let us see how it works. Let us draw the dotted line like this, like this. So if you don't have this feedback, these lines will be going to the output directly like this, right? So this is the output voltage which is going at the output directly, right? If you don't have sampler. But if you have sampler, so I need to take sample of output voltage. So you please see, if suppose there is a one voltage source like this. Fine. There is a voltage source like this. I want to take sample of this. That means I want to take this voltage as a sample. So that voltage as a sample can be taken like this. If this is plus V, this will be plus V. It means this voltage. So for taking the voltage as a sample, I need to take parallel, parallel tapping from the output. Fine. So this type of tapping is known as shunt tapping, shunt sampling, right? So to take this, I need to connect this and this. So from here, I will connect it like this. From here, I will connect it like this. So this is voltage sampling. So from the output side, if you want to take output sample, output voltage sample, take the shunt sampling, means take the terminals from the output directly like this, output voltage like this. This is known as voltage sampling. Voltage sampling, so you can see this is going like this, so this is coming in shunt, so feedback and output is coming in shunt. These are in parallel, this and this is in parallel. So because of that, we call this as the shunt sampling. Parallel means shunt. So voltage sampling is shunt sampling. Please remember that. Fine. Please remember, voltage sampling is shunt sampling. So wherever we have this word, so I can write voltage here. I can write voltage here. Wherever you have shunt word on the output side, wherever you have shunt word on the output side, I am saying sampler side, you can write voltage word there. Fine. Please do remember this concept, and it is not explained in the textbooks. You won't be able to understand everything from the textbook. Fine. Now let us come to this side now. Series mixing. Voltage series mixing, series shunt I have already explained. Series mixing. When you have series mixing, so output signal of this amplifier is definitely a voltage signal. In series mixing, what do? We take the series connection of the signal like this. Please see that block diagram. I'll redraw the block of sampler. So this is sampler. This is sampler. Fine, not sampler, I'm sorry, mixer. This is mixer. Fine. So this is mixer. So it can mix voltage, it can mix current. Fine. So whenever you have series, so if this is the voltage at output VF, we have voltage across this, right? There will be some drop. We have voltage here, input, and what will be there? If you take KVL in this complete loop, you can take KVL in this loop. So there must be a voltage which is being fed to this circuit. I repeat, in series mixing, it is the voltage signal. I repeat, please understand, in series mixing, voltage is added. When voltage is added, what do? We connect different elements in series. Maybe voltage source is in series, maybe resistance is in series. So when you connect elements in series, different elements like this, one in series, then second in series, then third in series. So whenever you add something in series, voltage will be added. And when you add something in shunt, say this is current I1, this is current I2, so what is added? Current. So I want to say, when you have mixing here, and that mixing is series mixing. Why series? Because this voltage is coming in series, right? So series mixing is definitely a voltage mixing. Why? Because in case of the series combination of elements, this series, and this is also coming in series with this feedback element is coming in series with the supply voltage, or you can say output voltage of the feedback network is coming in series with the supply voltage. So that is definitely the voltage mixing. So series mixing is voltage mixing. You can see this word. So wherever you have series word on mixer side, I can write voltage. So wherever you have series word on mixer side, I'm saying on mixer side, so that must be a voltage signal. Interestingly, please see, shunt sampling means you are tapping the output voltage. Shunt sampling means voltage, and series mixing means voltage. So on output side, when it is shunt sampling, it must be a voltage signal. On input side, when it comes to mixing, it must be a voltage. So it is different. Output side shunt, output side voltage. Voltage sampling means shunt, voltage mixing means series. So on input and output side, the word will change. On output side voltage means shunt sampling, on input side voltage means series mixing. I hope you will remember this concept. This is very important for remembering all the concepts. So what we have concluded from here, from these nomenclature, we have concluded one thing. On output side, it is a voltage signal. On input side, it is a voltage signal. We are mixing the voltage. So what should be this amplifier? This is voltage amplifier. This is voltage amplifier, and gain of voltage amplifier is denoted by AV. Fine. Gain of voltage amplifier is denoted by AV. So V is the subscript. Fine. Now it is now something like this. I have plus minus voltage amplifier AV. Fine. And then we have feedback beta, and we have sample signal. Output signal is a voltage, input signal is of course a voltage. You can take VI or whatever. Fine. Right? So this is feedback signal VF. Right? So if you want to find the overall voltage gain of this amplifier, overall voltage gain of this amplifier after mixing, overall voltage gain, I will not be considering effect of RS and this. Fine. So we are not considering the effect. So I will be taking this side as VI, not this. Fine. VI. Before mixer I am taking VI, I will be taking VI. Fine. Or if you are denoting it VI, it is VI dash. Definitely it will be different because you are mixing. Fine. So just for mathematical notations I am taking like that. So if you have derived the expression, I can derive that expression for you. As such you don't need, because you must be knowing the control system. But in one case I can derive that expression. What is this voltage? What is the voltage here? VI. What is the voltage here? It must be VI minus VF. So voltage here is what? VI minus VF. I hope it's clear. And now please see it carefully. VF is what? V naught into beta. So beta into V naught is VF. So what is V naught? You please see carefully. V naught is AV into VI minus VF. I hope you know. This gain multiplied by voltage input to this gain is VI minus VF. So AV into VI minus VF is the output voltage, right? What is VF? Beta into V naught. So this will be giving me, that is AV into VI minus that's what, beta into V naught, like this. Or you can see that this is V naught equal to AV into VI minus beta into AV into V naught, or this gives 1 plus AV into beta is equal into V naught is equal to what? AV into VI. I hope it's clear. So you can get ratio. Overall voltage gain of the amplifier AV with feedback is equal to V naught by VI, and that is AV divided by 1 plus AV beta. This is the overall gain with feedback. This is the general expression of the transfer function which you drive in control system. I have derived that expression here also. Fine. So what I have done, I have found the overall voltage, and I am not taking effect of this RS and VS. I am taking this voltage. I'm not including the effect of source resistance here. Fine, right? So I hope the concept is clear. So on the basis of this derived expression, I can write like this: overall gain AV with feedback is equal to AV with feedback is equal to AV by 1 plus AV into beta. This is very important expression. You must remember it. Fine. So overall gain, what has happened? Earlier, gain of this amplifier was AV, but because of this negative feedback, this is called negative feedback. Why negative feedback? If you see, this voltage and this voltage both are in opposite in polarity. If you come like this is voltage rise. Come like this, say this is VI dash, right? VI, so voltage rise, then plus minus voltage fall, plus minus voltage fall. So this voltage opposes this voltage. If it is voltage rise, it is voltage fall. So feedback is negative. When the feedback signal opposes the input supply, then this is known as negative feedback. So this amplifier has negative feedback. And when it is series, when there is series combination with the input supply, so that is series feedback or voltage feedback. This is the gain of that amplifier. I hope concept is clear. Fine. So this is very important expression. So gain of the amplifier, which was AV earlier, that has reduced by this factor. Fine. So this factor is, you can rewrite it like this: AV by D, where D is nothing but 1 plus AV into beta. So gain has reduced by factor D. D is 1 plus AV into beta, and this D is known as desensitivity. D is known as, this D is known as desensitivity, right? I hope you will remember this. So in denominator, the factor 1 plus AV beta is called desensitivity. We will see that reason why it is called desensitivity at later stage. But for the time being, remember the denominator is a factor D, which is known as desensitivity, right? Now, I hope all concepts are clear. Now, there are two more things you should remember. If I'll just explain. Here we have talked about signal, voltage signal, but now I will be talking about the input resistance. This is the resistance of the amplifier without feedback. This is the resistance of the amplifier with feedback. Fine. Similarly, this is the resistance of the amplifier. If you see from this side, the resistance of the amplifier without feedback, and if you see from this side, after feedback, after shunt, after sampler, this is the resistance of the output resistance of the amplifier with feedback. Input resistance without feedback after mixer, input resistance with feedback, output resistance before sampler, output resistance after sampler is output resistance with feedback. And you should remember directly rather than going into mathematical expressions. In case of shunt, you have shunt combination here, parallel. Shunt means parallel. In parallel combination, what happens to resistance? When you have two resistances in parallel, shunt, when two resistances are in shunt, this resistance and resistance in from this side, these are in shunt, right? When there is a resistance in shunt, what happens to the overall resistance? Decreases or increases? I hope you know about it. When resistances are connected in parallel, there is decrease in resistance. So the output resistance with feedback is R0 divided by 1 by AV beta. I repeat, the output resistance with feedback reduces by factor D because it is shunt, and in shunt means parallel. In parallel combination, resistance decreases. This is the concept you should remember, and this is the way you should remember. From series and shunt word itself, I will be able to remember these expressions, and these are very important expressions from examination point of view. You have number of questions the question is like that: what is the effect on the resistance in voltage series feedback? So output resistance decreases. That is one question, or they may be asking this expression itself as the question. Now come to input side. This is Ri. I have some series combination, and in series what happens? In series combination, resistance increases or decreases. It will be offering some resistance here like this, right? And in series combination, resistance increases. So in case of the series mixing or voltage mixing, series mixing is voltage mixing. Shunt sampling means voltage sampling, right? So in case of series mixing or voltage mixing, input resistance of the amplifier increases by how much factor? This factor is very important. Ri into D. This factor, D sensitivity factor, is very important. You will find every quantity increases or decreases by this factor in feedback amplifiers. So from that angle, that becomes very, very important. Fine. So input resistance in series means adding of resistances. Shunt means decrease in resistances. So in series type of mixing, there is increase in input resistance by factor D, which is D is the D sensitivity. These are the only points in voltage series and series feedback amplifier or feedback topology. Fine. So I hope the concept is clear to you. Now I will talk about current series. Current series. So in current series, I have already explained output side current means that is sampled signal, right? Current series. Now when current series is also known as series. I'm sorry, in previous case I have written shunt here, series here, but that was shunt. That was a mistake. Please rectify if you are making notes. So voltage current series is series, right? Current series is series. Please make that correction in your notes if you are making notes. Voltage series is series shunt. I have written a series here. That was a series. That should have been series shunt. So you can make correction, right, in your notes. Now current series. So output side is, this is output side, this is input side. But here on this side, this is input side, this is output side, right? So output signal is current. From this word itself, you know, output signal is current, right? And current sampling is known as series sampling. Let us see that. Suppose I have output current I naught. So if you want to take sample of output signal, what do you need to do? You connect this circuit in series of the output so that this current, complete current, passes through the feedback network. I repeat, in earlier case I was taking output voltage at the input of the feedback network. Now I am not taking output voltage. I am taking output current through the feedback network. This type of sampling where output current passes through the feedback network is known as current sampling. In case of voltage sampling, output voltage was coming at the input of the feedback network. When output voltage comes directly at the input of the feedback network, that is voltage sampling. When output current passes through the feedback network, that is current sampling. But now for passing the output current through the feedback network, I must connect feedback network in series. So series sampling is current sampling. Shunt sampling is voltage sampling. You must remember, everything should be in your tips. When you talk about shunt sampling, it is voltage. When it is series sampling, it is current. Fine, like that. Now current series. So input side is series, output side is current. Output side is current, input side is series. So in case of series mixing, we have already seen series mixing means voltage mixing. Series mixing means voltage mixing. So that means input signal must be a voltage. When it comes to series mixing, that is voltage, I have already discussed in detail. And so input signal is a voltage, output signal is a current. What is that type of amplifier where output signal is current, input signal is voltage? That is the trans resistance amplifier. That is what? That is trans resistance amplifier. So this type of amplifier must be a trans resistance. I'm sorry, output signal is current, input signal is voltage. When output signal is current, input signal is voltage, that is trans conductance. Why? Output signal current upon voltage. Current by voltage is trans conductance, not trans resistance. That was, there is a correction. So that is trans conductance. So this is trans conductance amplifier. Fine. And in case of trans conductance amplifier, this gain is denoted by G, capital G we take, right? Beta remains as it is. And everything will be similar. Output signal is current, input signal is voltage, amplifier is trans conductance. If output signal is current, that is series sampling. If our input signal is voltage, that is series mixing. On input side, if it is voltage, that is series mixing. On output side, if it is voltage, that is shunt mix sampling. Of input side, on output side, if it is current, that is series sampling. You must remember these concepts. Fine. So everything will be similar here. So in case of the feedback, gain with feedback, just simple replace that AV by GM. Otherwise, everything is exactly same. We don't need to drive the expression. I have already derived. The only thing is change of symbol. I have changed that symbol. That's it. Fine. So gain of the amplifier with feedback, which like this. So this desensitivity is in this case is 1 plus GM into beta. D remains desensitivity. Now come to output side. This is output resistance with feedback. This is output resistance without feedback. And you can see if this is coming in series, so it must be offering some resistance. So this resistance offered by feedback network plus this resistance must be the output resistance. So that means what is the effect on output resistance? Output resistance in case of series sampling increases by which factor? By D. So output resistance in case of series sampling increases by 1 plus GM into beta, and that is equal to R naught into D. So when it comes to word series, now the concept is when word comes series, it must be increased. When word comes shunt, it must be decreased in the resistance. So output is series sampling, output resistance increases by factor D. Input is series mixing, input resistance must be increasing by factor D. So whenever it is series, there is increase in resistance. When it is shunt, there is decrease in resistance, whether it is input side or output side. This is the basic concept. You should be remembering. Just by nomenclature of the amplifier, I can tell whether there is increase or decrease in the input and output resistances. That's it. Fine. So first you should know how to remember the topologies, different names of the topologies. That is first you need to know. Second, on the basis of the names in the topology itself, I can tell whether there is increase or decrease in the resistance. I repeat, 50% questions comes from this concept. 50% questions from feedback amplifier. You will find a lot of questions. Fine. Now, let us talk about the next amplifier, voltage shunt amplifier. And now the concept must be clear. Voltage in this nomenclature, this is output side, this is input side. In this nomenclature, this must be input side, this must be output side. Fine. Input side, output side. So this is voltage shunt. So voltage sampling on output side, shunt mixing on input side. Voltage sampling is also known as shunt sampling, output side, and this is shunt mixing, so shunt. So I will change the word here. Let us talk about third one is what? That is voltage shunt, right? Or shunt, shunt. And I have already discussed that is output side, this is input side, and in this case this is output side, sorry, this is input side, that is output side. So output side is shunt sampling. I have already given that word, shunt sampling. So in case of shunt sampling, what do we have? In case of shunt sampling, it goes like this. And shunt sampling is a voltage sampling. And if it is voltage sampling, what will happen to the output resistance? Output resistance will decrease because it is shunt. So output resistance will decrease. I will simply write like this, or R naught by D. Right? But I need to introduce this formula first. Let us talk about input and output signal. Later on I will discuss these parameters. Fine. Now input side is shunt. In case of series mixing, it was voltage mixing. Now word itself is indicative. Voltage shunt, input side is shunt, it is not series. So series was voltage, so shunt must be current, and that's like this. Let us see that. You connect it like this without feedback, and to mix the current, to add up the current, how do we add up the current? You simply take shunt combination like this. If this is input current I in, this is feedback, so what will happen here? This is feedback IF. So what will be current here? That must be I minus IF. I minus IF. Fine. So that is how it will change. This is I input, this is I minus IF. Right? Why? Because if you apply KCL here, incoming current is I in, output current is this current, outgoing current is IF. So what is this current? I minus IF. So I have subtracted the current, and if you take that signal here, that block diagram here, this is plus, this is minus, this is mixer. So if this current is I, this current is IF, what will be current here? I minus IF, and this is called shunt mixer. This is what? Shunt mixer. So in case of current mixing, it is shunt mixing. In case of voltage mixing, it is series mixing. In case of current sampling, it is series sampling. In case of voltage sampling, it is shunt sampling. So both are reverse. On output side, shunt means voltage. Input side, shunt means current. Output side, series means current. Input side, series means voltage. I hope you will remember the concept. I have repeated a number of times. Concept must be clear. Now, the output signal is what? Voltage here now. If output signal is voltage, input signal is what? Current. Output signal is voltage, input signal is current. What is that type of amplifier? Trans resistance amplifier. Voltage upon current. Output is voltage, input is current. Voltage upon current. So that is trans resistance amplifier. So this amplifier is trans resistance amplifier. I hope the concept is clear. It must be very clear by now. Fine. And for trans resistance amplifier, gain is denoted by what? Rm. Fine. So the gain with feedback will be definitely RMF, Rm divided by 1 plus Rm beta. Fine. Gain in case of trans resistance amplifier is denoted by Rm. So this is Rm here. Fine. I hope that formula and that concept is clear. Now, what will be this? Now, output resistance, it is shunt sampling. It is shunt sampling. So, output resistance must decrease. So, R naught by 1 plus Rm beta, or that is R naught by D. Now, please see it carefully. This is parallel combination. This and this both are coming in parallel. So that is shunt, and shunt means decrease in resistance. So our input resistance in case of your this amplifier must be decreasing. Fine. So input resistance must be decreasing here. I'll take just One moment. So increase, why? Because it is shunt mixing, and in shunt mixing, input resistance with feedback decreases Ri by 1 plus Rm into beta, or that is Ri by beta. I hope concept is clear. Not beta, that's D. This is D. Fine. So this is your voltage shunt or shunt. We are left with last one, current shunt. So this must be output, this must be input. Fine. Or this side, input first, output later. So this must be input, this must be output. And now from the name itself, output is series. So output resistance increases, input is shunt, input resistance decreases. By what factor? D. So from the name, in output side is current and current sampling is series sampling. So output resistance increases. Input side is shunt, and shunt mixing means input resistance decreases. So from the name itself, you can just write these formulas, and these are the questions basically. So let us talk about last one, that is I have already explained, but just for sake of the clarity of the topic. This is fourth one, that is input side, output side it is current, output side it is current shunt, right, or that is what, shunt series, right. So this is output, this is input, this is now input, this is output. So output is series sampling, and series sampling, how to take series sampling, I have already discussed that. This is series sampling. Input side is shunt, and input side is shunt, this is shunt mixing. So if input side is shunt mixing, that is current. So input signal is current, shunt mixing means current. So in case of shunt, it is current which is being mixed up. So input signal is current and it is series sampling, so output signal is also current. So what is the type of amplifier? Current amplifier. Output signal is current, input signal is current, so it must be current amplifier. And for current amplifier, how do we denote that current gain? AI. Fine. So now the current gain with feedback will increase or decrease. Current gain with feedback will be definitely, we have already seen the expressions. So current gain, expression of current gain here is AI this, where D is nothing but this factor 1 plus AI into beta. So this must be current amplifier now, right? Output signal is current, input signal is current, so that is the current gain with feedback. Fine. Now output resistance, it is series sampling, series means increase, so output resistance of this amplifier increases by, that is R0 into 1 plus AI into beta, or that is R0, that is what, R0 into, I'll just take a moment, that is equal to R0 into D. Input signal, input mixing is shunt mixing, and shunt means decrease, so that must be decrease in the resistance Ri by D. So these are the concepts, the formulas, the expressions, and from this much whatever I discuss, you will get 50% of the questions. So I hope the concept of series shunt is clear, concept of voltage series, and you can simply, suppose I have voltage series, so I can write it voltage input, this is what, input signal, sorry, this is output signal, output signal is voltage, mixing is series. So voltage amplifier. So series mixing means voltage. So voltage amplifier. Series mixing voltage, so current voltage amplifier. Shunt mixing is current, so voltage current amplifier. Shunt mixing is what? Shunt mixing is that is shunt mixing is current, so voltage current. Shunt mixing is current amplifier. So that is how different combinations are possible. So depending upon question given to you, you should be able to strike it now, right? So but in these two nomenclature, that is how we represent the different amplifiers. I hope the concept is clear and you will be able to do all the questions based on the feedback amplifier now. So this is all about different feedback configurations, and after that I will be talking about the characteristics of feedback in next video. So wait for my next video. Thank you very much for watching the video. But one important thing is, if you are able to understand, please share my videos with your friend, ask them to subscribe the channel, because that will boost up my morale to give you more and more. Thank you very much for watching the video.